Okay. This is probably the most complex one-dimensional physics problem you're going to get. And for those of you who hate word problems, I'm sorry. This is what we got. We got word problems. So I've got a person. The person is going to take a trip. And it's just like we're explaining what this person is doing. We're going to do position versus time. And we got our person on a trip. So our person is taking a trip and they're going to start at a stop sign. They're going to travel for 250 meters and they're going to achieve a final velocity of 15 meters per second. At that point, they're going to travel for another 20 minutes at that constant velocity of 15 meters per second. And at that point, what they're going to do is they are going to accelerate at 3 meters per second squared for 10 seconds, and then they're going to travel for 10 more minutes. Now, I made up these numbers, so we may be speeding down the highway. We'll just have to play with it. We'll see what happens. We're going to travel for 10 more minutes at the new velocity, at which point we're going to decelerate to 0 meters per second over 90 seconds. We want to calculate the total time. We want to calculate the total distance traveled. And we want to calculate the average velocity for the trip. So that's what we're going to do. So that's the full-blown problem here. So what we're going to do is we're going to take it in parts. So the first part I'm going to do this part. That's our first part. So what we know for the first part is we've got our person's in the car, and we're going to travel 250 meters. And we're going to be at 15 meters per second. We're starting out at 0 meters per second. And we're going to get some information. Now, remember, we have a toolkit, right? We have a toolkit. Our toolkit says our change in position is equal to our initial velocity times time plus 1/2 our acceleration times time squared. We have that my final velocity squared is equal to my initial velocity squared plus 2 times my acceleration times my change in position. And we have that my final velocity is equal to my initial velocity plus my acceleration times time. Well, for this problem here, we have an initial velocity is equal to 0 meters per second. We have my change in position is 250 meters. And we have a final velocity of 15 meters per second squared. All right? Okay? So we've got some interesting things here. We don't have time. But we're going to need time for our problem. We have our position. So the first thing is, for this part of the problem, our distance was 250 meters. We're going to need that later, so we're going to write that out there, but I need time, and I don't have acceleration. Well, the problem is, this problem requires acceleration. This one will give me acceleration. And this one requires time and acceleration. So I'm going to use this equation to find acceleration. So we can do that. So I get v final squared minus v initial squared is equal to 2 times my acceleration times my change in position. So I get v final squared minus v initial squared divided by 2 times my change in position is going to equal my acceleration. So this is going to be 15 meters per second squared divided by 2 times 500 or 22 times 250 meters is 500 meters. So I went ahead and did that calculation just so that I could keep my paper clean. And this gives me meters per second squared. So I know I'm doing this right. So that's great. So I get my handy dandy calculator out. And I get my 15 squared divided by 500 meters. And this says that I had an acceleration of 0.45 meters per second squared. Now I want to find my time. So I'm going to use this one. V final is equal to V initial plus my acceleration times time. My initial velocity was 0. So my final or divided by my acceleration is going to give me the time. And so now I have my 15 meters per second divided by my 0.45 meters per second squared. I'm going to end up in seconds. So that's really good. So there's my seconds. 15 divided by 0.45 gives me that this was 33.33 seconds. So for this first part of my trip, I now have my time. So I'm going to draw this. So we're going to draw our trip here. So this is from our first part of the trip. And this gives me my 15 meters per second. We started at 0 meters per second. The time is 33.33. The distance is 250 meters. And my acceleration was 0.45 meters per second squared. Now we're going to do this next part. This next part. We're going to travel for 20 minutes. Oh, everything's in seconds. So I better figure out my time. So the time for this is going to be my 20 minutes. And there are 60 seconds per minute. So I'm going to be able to calculate my time. And that gives me 1,200 seconds. So there's my time for this one. We know that this is still 15 meters per second. So my acceleration in this case is 0 because we stayed at a constant. But I need distance. Well, distance is my velocity times time. So that one's going to be pretty easy. It's going to be 15 meters per second times my time, which was 1,200 seconds. So my distance in this case was 18,000 meters. So now we've done the second part of the equation. So I'm going to go ahead and box this one in. This was our second part. Right? Now we're going to do this third part. But this is going to be 2 parts. So we're going to come back and look at this. We're going to get a little bit, and then we're going to go and travel a different time. So this one, this has a time of 10 seconds, and this has a time of 10 minutes, which means that it's going to be 600 seconds. So we actually have 2 parts to this one. So we're going to come back to our diagram here in just a second here. So we're going to do this first part. The first part is we're given our acceleration is equal to 3 meters per second squared. We're given our time is 10 seconds. Our initial velocity this time is 15 meters per second. We need to know our final velocity, and we need to know the distance traveled. This part we need to know for the problem. This part we need to know for the next step. So we know that V final is equal to V initial plus my acceleration times time. So this is 15 meters per second. My acceleration was 3 meters per second squared, and we did that for 10 seconds. So now we're going to get 15 meters per second plus 30 meters per second. Again, I made up my numbers, so this is going to be pretty fast. We're talking maybe a hot rod motorcycle or something. We're definitely breaking the speed limit. So this is 45 meters per second. Because remember, 60 miles per hour is 27 meters per second. We're going a little fast. We'd get a speeding ticket. But now we need to know the distance. Well, the distance, I can do this, is my initial velocity times time plus 1/2 my acceleration times time squared. So this is 15 meters per second times my 3 seconds plus 1/2 my 3 meters per second squared times my 3 seconds squared. This is going to be 45 meters plus 1/2 3 and times 9. So this is going to be plus this is 13.5 meters. This is 45 meters. So now I'm at 58.5 meters. So here for this little section, time was equal to 10 seconds. Distance was equal to 58.5 meters. And now we have our velocity at the start, and our velocity at the start of this part is 45 meters per second. We're going to travel that distance. We don't have an acceleration. The acceleration is equal to 0 here. We're going to get that distance. That's my 45 meters per second times my 600 seconds. So distance is going to equal oops, I knew that not right. This is going to equal 2,700 meters. Now we're going to do the very last part. At the point which we're going to decelerate to 0 meters per second over 90 seconds. So here we know the time. We know our final velocity is equal to 0. Our time is equal to 90 seconds. We need to figure out our acceleration. We need to figure out our distance. So we'll come over here and we'll do that. So we know that time is equal to 90 seconds. Our initial velocity was 45 meters per second. Our final velocity is 0. I need time. Oh, we know we have our time. I need acceleration, and I need distance. V final is equal to V initial plus my acceleration times time. My final is equal to 0. My initial is 45 meters per second plus my acceleration, and my time is 90 seconds. I'm going to get minus 45 meters per second divided by 90 seconds. I'm going to get a negative 0.05 or negative 0.5 meters per second squared. So now I want to do my change in position. That's going to equal my initial velocity times time plus 1/2 my acceleration times time squared. This is going to be 45 meters per second times my 90 seconds plus my 1/2, a negative 0.5 meters per second squared times my time of 90 seconds squared. So 90 squared times 0.5 times 0.5. This is going to be a negative 2025 meters. This is 4050 meters. Yep, 2025 meters. So now for our last little bit, we know the distance. The distance was 2025 meters. So we want to know total time. Time total is going to be the sum of each of these individual times. So we're going to add all of those up. So now I get 1933.33. This is 700. That's 19.333. So I think that's right. We get that time. My total distance is 250 meters plus 18,000 meters plus there's my 58.5 meters plus my 27,000 meters plus my last 2025 meters. Add all of those together. And I get 47,333.5 meters. The last thing we were asked, what was our average velocity? That's our average velocity. That's our total distance. That's 47,333.5 divided by, and that's in meters, my total time, which was 1933.33 seconds. And that gives me 24.5 meters per second. So hopefully this problem helps because we did a whole variety of the types of problems that you would have or the types of calculations that you would have when you're doing one-dimensional motion. Questions about that?